you should also have to, as it says here, explain your thinking. So be prepared to write a narrative. Yeah. Capital paper. Performance event. You want to write it down on one of your little papers and I'll drop it in the suggestion box? All right, find the rule and the 10th term of the following sequence. So the first thing we should do here is identify the type of sequence. What type of sequence is this? It is geometric. How can I tell that this is geometric? There is a common ratio. The common ratio here, it looks like the numbers are being divided by 3, but dividing by 3 is the same as multiplying by 1/3. Okay, so we would use the formula for a sequence where we can say that any amount you can do f of n, you can do a of n. I forgot how we used to do it. Let's do like a of n. Some amount is equal to. What's the what comes first for a geometric sequence? Who remembers? First amount. So a sub 1 times that common ratio to the power of n minus 1, right? So in order to be able to find the rule, we need the first amount and the common ratio. What's the first amount here? So a sub n is equal to the 9 times, what did we say the common ratio was? 3. What is the common ratio here? We're going from left to right. What are you multiplying by? 1/3. 9 times 1/3 to the power of n minus 1. That would be the answer to the first question. Remember that these problems are assessed on a rubric. So it's not an all or nothing proposition. There are gray areas. So some answers would lead to more points than others. It is somewhat subjective. Yes, ma'am. This is going to be paper and pencil. Here. All right, so then the last thing would be to find the 10th term, which is what we're being asked to do. So we're just going to plug in a 10 for n. So 9 times 1/3 to the 10 minus 1, which is 9 times 1/3 to the 9th. That's going to be a pretty ugly number. I'm probably not going to want that as a decimal. And they have them all as fractions here. So let's see. Let's just add, what's 1 to the 9th? What's 1 to the 9th power? It is 1. 3 to the 9th power, that shouldn't be too bad. Yeah, 19,683. So that would be then 9 over 19,683, and that can be reduced. I know that it can be divided by 9 because that 19,683 came from multiplying 3 times itself a bunch of times. Actually, you know what? Yeah, it should. So 19,683 divided by 9 is 2187. So I get 1 over, 2187. 1 over 2187. That is the 10th number. In order to be able to get through all of these today, instead of me writing a narrative, what I would tell you, if the questions are structured in a way that you do have to indeed explain your thinking, I'll mention some key words that I'd be looking for. I don't really grade these things too much on grammar. I realize that English is not everybody's first language. In some cases, that might not even be your second language. So I don't care too much about punctuation, commas, periods, spelling is not the most important thing, but I do look for keywords. Okay, so what are some keywords you should think that should be here if you were to explain verbally what it is that we did. What are some keywords that will probably be here? Geometry, no, but I would like geometric sequence and geometric sequence would be good. I'm gonna write equation. Sequence, yeah. Any other keywords? Yeah, common ratio. Okay, you can say what the common ratio is. Uh, yeah, sure. You can talk about the initial amount. Yeah. Obviously, you'd have to, you are the one writing the sentences. But questions there? All right. Find the rule. Okay. Or another word. What's another word for rule? Law. No. Another word for rule. When they say find the rule, told me to find the rule in the first one. That's what I wrote. Equation. Find the equation. Find the function. It's actually another. Really, most places call it find the function rule. Um, so sometimes they'll say definition, explicit rule. So find the rule for, and then find the 27th term. So let's first find the rule. In order to find the rule, we need to figure out the type of sequence. What type of sequences does it appear to be? It does appear to be arithmetic, and it appears to be arithmetic not just because the last one was geometric, and one of these we have to have one of each. It's because these have a common difference. Each one is going up by 2.5, it appears. So the formula for that was, I'll write it down one time, the initial amount plus that common difference times n minus 1. Not that you necessarily have to write that, even though that could be part of your explanation, I guess, if you want to. So any amount is equal to, what's the first amount here? Come on, use your words. Thank you, Marquise. 3 plus the common difference, which is 2.5 to the n minus 1. If you leave it like that, that's fine. But when it comes to arithmetic, like actually the geometric sequences a lot of times can be simplified also, but you don't see it done as often. This is a little bit more conducive to simplification because you guys are used to distributing by multiplying. So another thing you could do is just say distribute the 2.5n minus 2.5, and then when you combine like terms, you get 2.5n plus 0.5. But either one of these would be okay. I'm not going to scrutinize between those two. The nice thing about simplifying is that you could argue, though, that if you do simplify, that makes the second part easier. What is the 27th amount going to be? It's just going to be 2.5 times 27 plus 0.5. 54, 13, 68. Is it 68? Take that, mental math. So that's the second question. I'm not going to write the paragraph for you, but again, what would the word be? The compromise here, where I'm kind of meet you in the middle would be, I'm not going to be too strict on spelling. I mean, I hope you spell well, and I hope you know how to use periods and commas, and that your sentences have subjects and predicates and stuff like that. But I don't believe that I'm an English teacher, so I can only be so tough on that. But I can look for keywords. So what are some keywords that I would expect to see on this explanation? Yeah, you would say like that this is an arithmetic. You would describe this as being an arithmetic sequence. I would hope you would go into why it's an arithmetic sequence. Because these numbers have a common difference. Yeah, that would be another. Anything else? Yeah, you can talk about the initial amount again. Of the three, that's probably the least important one. But I mean, if you want to be more thorough, you can talk about how you came up with this actual because the initial amount was 3 and stuff. It's pretty good. Okay. State the formulas for exponential growth and decay and explain what each variable represents. This can be done in the same. I'm not gonna. I think other teachers gave this formula separate, but it's the same thing. The only difference. Then, do you guys remember what the only difference between growth and decay is? Yeah, it's either 1 plus or 1 minus, which yeah, okay, it does mean the base, but what causes that base, the growth factor, to either be greater than 1 or less than 1 is what the rate of growth or decay is. On a decay, the rate is negative. On a growth, the decay is positive. But from you only have to give me this one. The amount after some time is equal to the initial amount times 1 plus that rate of change to the power of time. Because really, if the common ratio, sorry, not the common ratio, if the rate of change is negative, that just assumes it's a decay. If you want to write both of them and you write the same, you could say that this is a growth, and then you could, rewrite this again and say A of t is equal to A sub 1 minus r to the t, and then say this is the decay. Okay, well then now by writing it twice, that puts less pressure on you to have to describe this with a narrative. I'm going to go ahead and write what each thing means, but I'm assuming that, when you get asked this tomorrow, it might ask you to elaborate a little bit. So like, okay, what does A sub t mean? Well, this is going to be a final amount. What is A? So if you look at your notes, I had this for you on the original notes. I had it when each thing meant initial amount. R is the rate of growth or decay, for that matter. But if you only write one formula, then you probably have to write something along the lines of when R is greater than 1, you have a growth. No, sorry, just kidding. When R is greater than 0, we have a growth, because that makes it positive. And when R is less than 0, that's a decay. Negative rates are decays, positive rates are growths. And then the last thing would be that t is time. Usually measured in years, but not necessarily having to be measured in years. Depends on what you're measuring. Any questions there? Sarah decided to save her graduation money in an investment that has 4% growth and compounds quarterly. How much will her investment be worth in 10 years if she received $1,000 in money? So the key here would be to know what does the word quarterly mean. Yeah, it implies the number 4. So the amount here after some time would be equal to the initial amount, A sub 1, times 1 plus the rate of change. But first you divide it by that word, like by quarterly by 4. But then you get that 4 and also multiply it times time. But it's going to compound 4 times in that year. So in this case, it's 10 years. So A sub 10 is equal to the initial amount, which is 1,000. It's a nice easy number to multiply by. 1 plus 4% growth. Bri. I remember this was one of your favorite things here. 4%, how do I write that as a decimal? 0.04, good. So 1 plus 0.04 divided by 4, and then 4 times 10. This one here, we pick nice round easy. We're gonna need a calculator eventually, but we can actually get by without the calculator for a little bit because I know 0.04 divided by 4 is 0.01, and I know when I add that to 1, I get 1.01. I can knock that out pretty easily without a calculator, but once I get to here, I'll need a calculator. Also remember that one of the things we stressed when we taught this was knowing how to round. What are we measuring here? Because how we round, or if we round, depends on what we're measuring. So what are we measuring here? We're measuring money. Technically, money is supposed to be rounded up, but I've seen some instances where they round to the nearest. So really, I'll take either one. The only times are when the nearest happens to be up, yeah, you better round up. But if the nearest happens to be down and you round down, it's fine. If you're off by a penny, it's not a big deal. So 1,000 times 1.01 power 40. I am getting and also make sure it's the nearest hundredth. See, so I'm getting here where you would actually be rounding down. So 1488.87, because money's supposed to be rounded up. But if you put 0.86 there, that's fine also. Either one would be fine. But 0.86 is the nearest, but 0.87 is up. Any questions there? Kiara? You have that formula memorized? Metro Atlanta has a population of 5,500,000 people. In 2021, the population is expected to be 60,72,444. What is the percent of growth each year on? I don't like this question because it doesn't say a beginning time. Let's just do this. I have a feeling that when this question was written, this question was not written in 2019. I have a feeling that this was written before, but let's just assume it's current, okay, that it is 2019. So if it's 2019, that means so I put my final amount first, 60,72,444 is equal to the initial amount, which is 550,000 times, we know it's growing, so this thing has to be positive. And they want to know what is the percent of growth. So it will be 1 plus some percent, some rate of growth to the power of years. Well, how many years have passed between 2019 and 2021? 2 years, yeah, so square. But if this question was written earlier, then I would have been higher. Now let's work on getting that R by itself. So the first thing you would do is divide by 50,500,000, divide by 5,500,000. And that's gonna give me a decimal. I'm just gonna leave it like that. I'll make sure that when I put it into the calculator, I'll use the parentheses. I'll keep that together because if not, that decimal is probably gonna be pretty nasty. So we have that 607,2444 over 550,000 is equal to 1 plus R squared. What would be the next step? Not divide. I need to get the R by itself. In order to get R by itself, I have to get rid of the square and the 1. What am I getting rid of next? Yeah, the square will be next. And earlier this year, you noticed something called square root property, which says that in an equation, you're supposed to also not only put consider the positive side, which is called the principal root, but you should also consider the negative side. problem is though, this is a real world, this is a word problem. We're measuring something here. We're measuring people. You can't have negative people. So in this case, I would ignore the negative end of it. I'm gonna leave that like that. Because again, it's just a nasty decimal, and I don't want to have to round too early. The earlier I round, the further I get from the actual solution. So I'll just leave it in its form like that, like if I can't simplify. And then the last thing I'll just do is subtract 1. The rate will then be by itself. And now this just becomes a calculator problem. Are you adept enough at the use of your calculator to be able to put this all in one shot? It's a lot easier if you have those multi-view calculators where you can literally just make it look like that looks like on the computer when you use Khan Academy and stuff. If not, you have to use it. Like on mine, I don't have a multi-view. So I'm going to have to do a square root in a parentheses. So square root parentheses 607,2444 divided by 550,000, close the parentheses, and then a minus 1. And I'm getting, this is a percent, I'm sorry, I might have said we're measuring people. But when we are measuring people, like those numbers there stand for people, but we're looking for a rate. So I'm getting about 32%. That the rate is around, let's even round, let's go about 0.3226. So about 32.26%. It's increasing. You got something different, Marquise? Okay, that part you got. Where was the minus 6 that I didn't get? Why can't I see everything you typed? Oh, there it is. There's the minus 1. So maybe I typed it wrong. Are you getting 30 or are you getting something else? Yeah, so that's probably me. I probably made a mistake. Square root of 607,444 divided by. I typed it wrong. It is 5%. And it's nice because it's 0.050, so it's pretty darn close to 5%, 5% growth. Sorry about that. Anybody else? All right, let's move on. A car is worth $20,000 and depreciates at 8% a year. What is the car worth after 15 years? So this is just a regular decay problem. I'm not even going to write the formula. Let's just say we want 15 years. So the amount after 15 years is the $20,000 that it was worth originally times what is the growth factor going to be? Or in this case, the decay factor. This is decay. 0.92. If you're losing 8% every year, it's about what you're retaining. You're retaining 0.92 for 15 years. Just put that straight into the calculator because those decimals are going to be nasty. Also, remember that we're measuring money, so we could be rounding to the nearest hundredth. And see, this one is already rounding up, so there would be zero reason here to round down. So this one, I would not take anything other than $5,725.95. Does the peanut gallery agree? Anne and Marquise? Okay. Any other questions, Kiara? Sam, I am. Number 7, Adam scored 78, 89, 92, 97, 88, and 85 on his first 6 tests. What are his current average? Okay, so I would just add those up. 78 plus 89 plus 92 plus 97 plus 88 plus 85, and divide by, that gives me 529. And I would divide that by how many there are, which is 6. That does give me a pretty nasty decimal. Well, it's not nasty, but it does go on forever. And they do not tell me where to round, so let's just round it to around 88.2. So I have confirmation from my fact checkers. Okay. What is his new test average if he gets a 0 on the 7th test? Well, if he gets a 0 on the 7th test, his scores are still going to add up to 529, but now instead of dividing by 6, we're going to divide by 7. And that gives me around 75.57. So let's just say, since we chose to go to the 10th, let's stay to the 10th, and let's just say 75.6. I don't mind rounding, but I hate it when problems, you have to round and they don't tell you where to round, because then everybody can get a slightly different answer. And then this is the one that, if you remember, this was originally a bonus question. Then it became a real question, and still people missed it, and we went over this in class. What does he need to score on the next test to have a 90% average overall? So now we just need to all right, let's assume that C ties into the original. Because if not, he might not be able to get to that 90 from a 75 on one test. I don't even think that's feasible for him to jump up to a 90. So let's just assume that next one, because sadly, I wish they wouldn't have used the word next test. I wish, just like up here, they would have used the word 7th test to be more specific, because you don't know if that next test is the 7th or the 8th. But I'm just assuming by looking at it, if his average drops to a 75, I don't think he could even get to a 90 even if he wanted to. So let's just assume it's the 7th. So now we're going to use the formula for average, but we want to get to 9. How do you write 90% as a decimal? So 0.9 is equal to the 529 points he already has. If you didn't want to write 529, then you'd have to write 78 plus 89 plus 92 plus 97 plus 88 plus 85. You'd have to add them all up. Plus Kiara, this next test that we don't know about. But then what are we going to divide by? By 7, because that would be his 7th test. You would multiply by that 7 to get rid of it. 7 times 0.9 is 6.3. Wrong. Okay. Sorry, I need to put since I put the 529 as a point, like I left it in percentages, I have to put the 0.9 as a 90. If not, I would have had to have put 5.29. So I need to leave this as 90. Because the 529 is technically still in a percent. All of those are percentages. So then that would be then 630 is equal to 529 plus x. And this also goes to show. Oh. You're gonna tell me that it's impossible then too? Are you guys also getting 101? What a terrible question. So yeah, you have to get 101. So there better be some bonus questions there, because otherwise you can't get 101%. And did you guys make sure that I added those first 6 correct? Did you also get 529 for that? Okay. Well, yeah, that's the key that some of you couldn't figure out before, is that you have to add that extra test that we're looking for, and then just divide by 1 more, and then make it equal to whatever you want it to be. Find the mean, median, mode, range, and interquartile range of the following numbers, and make a box plot and a histogram to represent the data set. So other than mean, pretty much all of these require you to put these in order. So there's 1, 2, 3, 4, 5, 6, there's 10 in the data set. Let's put them in order. 5, 5, 7, no, 5, 5, 5, there's 3 5s. Then a 7. then 11, 12, 12, 13, 13, 17. So let's first find the mean, which is 24, 6 plus 17. And that's 100 divided by 10. So my mean, or what's also known as x bar, have you ever seen x bar? That means mean. Let me write it because you're not paying attention. I don't know what it means. So mean is equal to 10. The average is 10. The median on a set that has 10 numbers in it, where do you find the median? The average of the fifth and sixth. The average of the fifth, 11 plus 12 divided by 2 is going to be 11.5. The mode, it is possible to have either multiple modes or no modes. But in this one, there is a clear mode. Which number appears most? 5. Interquartile range. If you have an even amount of numbers, you leave everything in and you just cut them in half. There's 2 teams. Each of these teams has an odd amount. Each of these teams are 5, so it's the number in the middle. What's Q1 going to be? It is 5. What's Q3 going to be? The 13 is in the middle there. So the interquartile range would be 13 minus 5, 8. Then make a box plot and a histogram. Okay, I'll just do quick sketches of these. Did I skip range? I did skip range. Okay, sorry. Range is max minus min. So what's 17 minus 5? 17 minus 5 is 12. So, sorry, let's squeeze that in here. Range is 17 minus 5, which is 12. Okay, now did I answer everything? Okay, so let's do the box plot. In order to do a box plot, we also need to know if there's any outliers. So outliers, we do 1.5 times the interquartile range, and that gives me 12. So are there any numbers that are 12 less than Q1 or 12 more than Q3? Well, no, nothing is less than -7. Nothing is more than 25. So the whiskers are going to go all the way to the max and min. You guys can draw a scale if you want, but I'll just keep this pretty simple. So there would be the 5, Q1 is also the 5. So actually it's not even going to have a whisker. This is just going to be 5 there. The median was 11.5. So the median would be kind of like there. This would be that would be that would be that. And then the only whisker is going to go out to 17. Why is there no left whisker? Because the min is the same as Q1. For a histogram is like a bar graph. There's more than one way to arrange this. You might want to arrange this in like, let's do it in 2. So let's do like, so this is going to be the frequency. So this will be, and there's no more than 3. So let's do 1, 2, and 3. This is the frequency. And then let's do like a 5 and a 6, then a 7 and an 8, then a 9 and a 10, 11 and 12, 13 and 14, 15, 16, 17 and 18. So between 5 and 6, we have 3. Between 7 and 8, we have 1. We don't have any 9s and 10s. We do have 3 11s and 12s. 13s and 14s, we have 2. 15 and 16, we don't have any, and then here we have 1. But there's more than one way that that could look. Questions? Shobi, she sent out the email now, so you're good. You start a career at 25 years old making $40,000 a year. Every year you get a 2% raise. What will be your annual pay when you are 55 years old? How much time is there between 55 and 25? So the amount after 30 years is equal to what you started with, which was 40,000 times. If you're getting a 2% raise every year, then it's 1.02 is your growth factor times or to the power of 30 years. Here we're measuring money, so we'll just put it in the calculator and round to the nearest hundredth. And I'm getting 72,454 and 46 cents. This one, 46 cents is rounding down, so I'm actually gonna put 47 cents, but if you put 46 on that one, that's fine too. Calculator, crew, you guys got the same thing? An arithmetic sequence has an a sub 5 of 18. Ooh, you know what? We saw this one. This one wasn't really part of the actual lessons, but we saw this on the EOC reviews. So this is fun. Arithmetic has a common difference, but they're not giving us a common difference. But what did we say common difference was the same as? As slope. So really we can use slope formula with these points. If the fifth number is 18, then this has a ordered pair of 518 and of 930. You can then find the slope, which is going to be 18 minus 30 over 5 minus 9. That's negative 12 over negative 4, which is positive 3. Now they want the rule, which the rule is the equation and the first term. Okay, we got the common difference, which helps. You could find the first term recursively, I guess, if you wanted to. Maybe that might be easier for some of you. So if you know the fifth term is 18, then the fourth term would be 15, the third term would be 12, the second term would be 9, the first term is going to be 6. You can go backwards that way, I guess, if you want to find the first term, but you can also find it algebraically. Pick any one of these points. What, Nakai, you want to pick the first one? Fine. Sounds good. You would then say, okay, 18, because I just happened to pick the first one, you should be able to pick either one, is equal to this first amount that I'm looking for, I'll just leave it as an A, plus I just found the common difference. And what term was that 18? The fifth term, so I would write 5 minus 1. The key here being that the only variable, the only unknown is the first term. 5 minus 1 is 4. 3 times 4 is 12. So it's A plus 12, and as I said before, the first term ended up being 6. So now that I have all that, my rule would be A sub n is equal to the first one, which is 6, plus 3 times n minus 1. That would be fine, but if you choose to simplify it, you could distribute like Caleb does. 3n plus 3. What word can be used to describe the rule or the explicit definition of an arithmetic sequence? Very good. Is this the last one? The equation h equals negative 16t squared plus 64t plus 80 models the height of a ball. Models the height of a ball's height after t second. What is the height of the ball after 2 seconds? Okay, so the key is second. This function is comparing height to time. Is 2 seconds a height or a time? A time. So I want to put the 2 where the t goes. You can plug it in the long way, or look, here we go. Hash brown TBT. If you remember this from way back in the day, I taught you synthetic substitution. How many of you remember this? How many of you liked it? Quicker, I think, but it's up to you. You can now you can put the 2 in the long way. So whatever I'm looking for is going to end up here. Drop the negative 16, negative 32, 32, 64, 144. We're measuring height. It doesn't tell us the height. The ball's height h. Son of a gun. Let's I guess feet makes sense maybe. If it doesn't tell you, you don't have to, but that's gotta be that. Am I reading it wrong? I'm not seeing a unit for height. Let's just say 144. If they give you a unit tomorrow, write the unit, but there's no unit there. What's the maximum height the ball will reach? All right, so here's another key word we learned this year. This was kind of a blend. This went towards we learned it at the end of the first semester, but it did blend over into the beginning of the second semester back in January. What does maximum mean? The vertex. Okay. I feel like I've seen this problem before. I feel like I've seen this because I already knew what C was going to ask. And it's this: when does the ball reach the maximum height? So watch. In order to be able to find the maximum height, I first have to know when. Because on that vertex, this is, look, you see this negative up here? This means that if I were to draw it, this would be a downward facing parabola. And I'm looking for how high it gets. You remember when we did the maximum parabola, we called it h comma k? That's actually what I'm doing now with my trailer courses, the ones that are still taking first semester. So I have to find the h first. I have to figure out, like, not the h here in the equation. I'm talking about the h of the vertex, like at what time it gets there. Who remembers that formula for h? Negative b over 2a. So that'll be negative 64 over 2 times negative 16, which is negative 64 over negative 32, which is 2. Well, look at that. So I've already even answered my question. Because it's going to take 2 seconds to reach the maximum height. And I already happen to know from doing the work up here, how high is it going to be after 2 seconds? Yeah, it'll be 144, whatever. Feet, meters, whatever unit they're measuring in. Just don't forget that you typically have to write some type of a unit, but I just don't see the unit there. After how many seconds will the ball hit the ground? Okay. When a ball is hitting the ground, is that a measurement of time or of height? Height, because how high are you off the ground when you are on the ground? 0. So you put a 0 where the height would go. 0 is equal to negative 16t squared plus 64. I also feel like didn't we do this recently also? Wasn't this like part of a test and I went over it like with Ann? I feel, because I remember saying how Ann likes to factor these. Most of you might like quadratic formula. I will provide you with a reference sheet. So that has quadratic formula on it if you want to. And A would be negative 16, B would be 64, and C would be 80. But if you can factor, you might want to factor. This is a negative, they all have a negative. So this would become t squared minus 4t minus 5. Can you think of two numbers that multiply to give you -5 and add up to -4? -5 and 1, so -16, t minus 5, t plus 1. When you use zero product property, you can ignore the -16, it makes no difference. But t minus 5 equals 0, and t plus 1 equals 0. So we get that the time is 5 seconds, and the time is -1 second. So unless you have a time machine and you can't go back in time, how long is it going to take the ball to hit the ground? Any other questions for me? Any questions for Caleb? Okay. Performance final tomorrow, or the PFE, as some people might call it.